All right, the next 2 days we're going to be learning some other derivatives, and today we're going to talk about the derivatives of the sine and cosine. So after doing the toothpick tangents, we have found that the derivative, so d over dx of the sine of x is equal to the cosine of x, and the derivative of cosine of x is equal to negative sine of x. Right, and that's something that you're going to just need to memorize. We'll talk about it. We'll practice it a lot, and eventually you'll have it just hopefully in your brain permanently. I also want to just make a note of the constant multiple rule. And that's when you have the derivative of a constant times a function. That's just going to be equal to the constant times the derivative of the function. You're just going to multiply by that constant. Okay, so you're going to do a couple of examples. So for example 1, we're just going to find the derivative. All right, so A is y equals 2 sine of theta minus 4 cosine of theta. Right. So to represent the derivative of y, I'm going to call it dy dx. We could do y prime, either one. All right. So then if I wanted to take the derivative of 2 sine of theta, is going to be 2 times the derivative of sine of theta, which is going to be cosine of theta. All right. And then negative 4 times the derivative of cosine is going to be negative 4 times negative sine. So that's going to be positive 4 sine theta. Okay, so we use the opposite sign when we do the derivative of cosine. All right, for B, f of x is equal to x to the 4th minus sine of x. All right, so the derivative, f prime of x, for x to the 4th, we're going to use the power rule for derivatives. And then the derivative of negative sine of x is going to be negative cosine of x. Okay. So just anytime you take the derivative of sine of x, you get cosine of x. Anytime you take the derivative of cosine of x, you get negative sine of x. All right, and this last example, we're going to do more. So for example 2, we're going to determine the points, if any, at which the graph of the function has a horizontal tangent. All right, so think about what it means for a graph to have a horizontal tangent. So really, what we've been talking about lately is the derivative. So we're definitely going to have to do derivative. So for a derivative, it gives you a slope. So what is the slope of a horizontal tangent? The slope is going to equal 0. So what that means for us is that the derivative is going to equal 0. All right. So what we'll do is take our function and find the derivative first. So let's just do it one step at a time. So our function is y equals x plus cosine of x. Now we're only using this for x's that are between 0 and 2 pi. All right, so if we want to find a horizontal, where there's a horizontal tangent, we have to find the derivative. All right, so the derivative of x is going to be 1. The derivative of cosine of x is negative sine of x. So that's step 1, find the derivative. Step 2 is set the derivative equal to 0. So we're going to take that 1 minus sine of x and set it equal to 0. Now, you guys don't have a lot of experience solving trigonometric equations. We did it last year, kind of at the end of the year, right before we got out for COVID. So you have done this before, but it's been a while. We haven't talked about it this year. But what we want to do first is solve this equation for sine of x by moving the sine of x over to the other side. Now, what we're looking for now is an angle x whose sine is 1. Now, for sine and cosine to equal 1, it happens on the unit circle. It's a quadrant angle that's going to have a sine or a cosine of 1. Okay. So, if we went to the unit circle, we have 4 ordered pairs that we use. And if we're on the unit circle and we want to find the sine of an angle, we're looking at the y-coordinate. If we want to find the cosine of an angle, we're looking at the x-coordinate. So since we want to know what angle has a sine of 1, we want to know when the y is equal to 1. And that's at the angle pi over 2. You also could go to the graph. Think about the graph of sine of x. So this is going by pi over 2 each time. All right, so this is 1, this is negative 1. We want to know when the sine is equal to 1. That's up here. That's when the sine is 1, and that's at the angle pi over 2. So either way, you need to know a way to solve that equation. All right, so we have figured out the x-coordinate. We want the whole point. So we need to find the y that goes with this pi over 2. And anytime you're looking for a point on the original graph, we go to the original function, y equals x plus cosine of x. And I'm going to plug in my value of x. Okay. Now we are going to need to be able to find the cosine of pi over 2. So that's not, didn't mean to erase all that. That's not too terrible. We can go back to this unit circle that we drew. When we're looking for cosine on the unit circle, we need the x-coordinate. So we look back, the x-coordinate at pi over 2 is 0. So that means that the cosine of pi over 2 is 0. Pi over 2 plus 0 is pi over 2. So our point is pi over 2, pi over 2. Pi over 2 for the x, pi over 2 for the y. Now, if you don't like using the unit circle and you like using the graph of sine and cosine, negative 1. So we look at the graph of cosine when x is pi over 2, the graph is at 0. So that's also another way to get 0. Okay, so your assignment, your assignment for today is on page 114, 20, 22, 24, 36 through 38, 54, 58, 61, 64, and 82 through 92